Hello. We will title this segment Seattle and the Discovery of a Novel Use for the Compound Adenine. The year is 1959. Now, the stellar event of that year was the birth of our delightful daughter, Carol. There were other significant events around that time. We moved to Seattle. It was my first commitment full-time to the discipline of hematology. It did lead to the most significant research accomplishment of my career, and it sets a stage for my future scientific career. Personally, it was also the time we bought our first house, and it was the first house that we owned in which Carol and Lori lived. But what I will do in this segment is concentrate on the steps leading to the development of the use of adenine in blood preservation. Now, blood is collected for transfusion, and in 1959, the shelf life, or the time it could be kept before it would no longer be usable, was 21 days, and that was discovered in 1941, and there had been no significant advance up till the time we are talking. And 21 days meant that for most blood centers in the United States, after collection, blood could be used for 21 days. And that meant that of the collected blood, anywhere from 5 to 10% would have to be discarded and was wasted. Now, for the military, the problem was much more severe. Blood, for example, was collected for the Korean War and also the civilian war in the United States. And it took about 10 days for it to be collected, tested, processed, and shipped to be available in the war theater, which meant that of the 21 days, almost half of it was wasted. The military obviously was tremendously interested in having an extension of the shelf life. And in fact, their target was about 42 days, or double this was what they were hoping could be achieved, because a doubling of the shelf life really meant a tripling of the usage of blood, because from 42 days, the processing of 10 days was the same. Now 30 days, roughly, was available. And so this was a goal which was well known. So that is the background. And what the addition of adenine, small amounts of adenine, to the coagulation, anticoagulant preservative solution achieved was to extend the shelf life from 21 to roughly 42 days. And this is essential. This was accomplished or discovered in 1960, 1959 to 1960, and adenine remains the essential ingredient, and with minor modification after 50 years, the same anticoagulant preservative remains in use worldwide. Now, how did this come about? Well, I have to go back to about 1956. Um, the military draft was still in place, and college graduates, and particularly medical school graduates, had the opportunity to volunteer for the service, for a 2-year service. And along with the military, there was the United States Public Health Service, and it was possible to serve your time as an officer in the United States Public Health Service. And I applied for a place at the National Institutes of Health, which I was granted. I got a commission in the Public Health Service, and off we went from San Francisco, where I had my residency at Stanford. Stanford was still then in San Francisco. We went to, even I went to Bethesda in 1956, where I had a clinical appointment in the National Institutes of Arthritis and Metabolic Diseases, but I had the opportunity to work in a laboratory. And early on, from some experience I had at Stanford, I was leaning toward hematology and became interested particularly in the red blood cell. But also at NIH, I first became interested in aging, which in retrospect is interesting that now I'm 82 at the time, and I'm still very interested in aging, but I was 27 at the time, and read what I could about aging, and learned, for example, that if one fed rats a complete diet in terms of what they required, all the essential amino acids, vitamins, and so forth, but restricted their caloric intake so that they would not grow to their full size if left to eat alone, they would live twice as long. Another observation was that the same species of fish that lived in a cold ocean lived twice as long as the fish who lived in a more moderate temperature, such as the Mediterranean. And there were other observations along that line, so the aging interested me. And I thought that the red blood cell, which might be a perfect model to study aging, because it is born and circulates for 120 days and then dies or is removed. And so the red blood cell has no nucleus, it doesn't divide in the circulation, and so it just is born, ages, and dies. Well, the problem would be then to separate old cells from not old cells and see if one could find any differences. Well, I tried and tried several methods to do that and did not succeed. I was able to separate young cells from not young cells, but not old cells from not old cells. And the second publication shows the results of separating young cells from not young cells. In any case, even though I did not succeed in that, it seemed important in order to study the red blood cell to know a little bit more biochemistry. So after my 2-year completion of my compulsory service, I applied for a fellowship and stayed at the NIH for a year to learn intermediary metabolism, and particularly carbohydrate metabolism, because I knew the red blood cell depended on carbohydrate metabolism. Incidentally, this was quite unique. So far as I know, the NIH had never accepted a fellowship from outside, and it was in the business of granting fellowships from NIH. So they had to set up a mechanism, and it probably cost them $15,000 to set it up, whereas my salary was $7,500. In any case, during that time, I worked on a number of problems, continued some studies about red cells, but became convinced that I wanted to go into hematology. I looked around and searched various programs, and the one that appealed to me most was that of Dr. Clement Finch at the University of Washington in Seattle. One of the appeals was not only that he offered a superb training in hematology, but he and his co-workers were working on extending the lifespan or the shelf life of blood. They had tried several methods, and sometimes they got some promising results, but they could not be repeated. But in the process, they worked out the techniques whereby one could study the shelf life of blood. And the specific requirement was that once blood was collected, it could be stored or have a shelf life so that at least 70% of the cells would survive in the recipient of the transfusion. So that was the criteria, and methods had been worked out to determine that. So both the training program and the fact that they were doing studies along extending shelf life and had the techniques to do so attracted me to the program in Seattle. Well, when I arrived, Dr. Finch told me about 2 grants that he had. One which had to do with extending the shelf life of blood, and that was an Army grant. For obvious reasons, the military was interested. But also, at the time, 1959, blood bags were relatively new, having been introduced in the early 1950s. And the requirement was that each lot of bags had to be tested to be sure that blood collected in it would permit a storage period for the time that was allowed at that time, 21 days. So Dr. Finch turned over both these programs to me, and initially the greatest interest was to verify or certify that the bags that Cutter manufacturers were able to sustain a shelf life of 21 days. He did not initially emphasize studies in blood preservation, but a coincidence happened in 1959 which whet my appetite. A paper was published uh, in, by the Japanese, a gentleman named Nakao, Nakao, uh, and he and his associates published a paper where they used 10-week-old blood and incubated it with the xanthine riboside called inosine and the purine base adenine. And they found that the shape of the red cell, which becomes crenated and circular after a long time storage in a blood bag, was able to be converted back to the biconcave disc. And they repeated that several times and showed, in addition, there were some chemical changes. Now, the reason it was known that the red cell normally uses glucose as an energy source, but it was also known that after several weeks of storage, glucose could no longer be utilized. On the other hand, the purine riboside, which is made up of this xanthine base and a ribose, which is a sugar, could enter the cell after long time storage and be used as an energy source. Now, the amount of inosine that was required would be such that it could not be used in humans because of toxicity, particularly toxicity on the kidney, and also it would produce essentially gout in anybody who received it. I was intrigued by the paper because I was not interested in rejuvenation of old cells. My interest was in the maintenance of the shelf life at the beginning of storage. So inosine was not necessary. Glucose was available, so I thought that why not just use adenine? So in the process of studying the cutter bags, I decided I would put adenine into some of the cutter bags and split the blood units so that some was studied without adenine, some was studied with. Now the problem was that adenine turned out to be extremely insoluble, and it was very hard for me to get it into solution. The Japanese reported that they were able to supplement with 10 units, I'll use the word units, per milliliter of adenine. Now, I tried every way possible to try to dissolve 10 units per mil in an aqueous solution, which was required to put into the anticoagulant preservative solution because it was an aqueous environment. Well, the best I could do was to get 4 units per milliliter. And so what I did, though, was I started with 0.5 units, 1, 2, and 4, and supplemented and then studied the bags at various periods. And it turned out it was an aha moment, or the moment of discovery, that the optimal adenine was 1 unit per mil. 0.5 unit was almost as good. Both of those achieved a shelf life of about 6 weeks, or 42 days. The 2 units was much less effective and 4 was actually toxic. So had I achieved 10, had I been clever enough or figure out some way to dissolve 10 units per mil, the discovery would not have been made. It turned out later that the translation of the Japanese paper was incorrect. It missed the decimal point. And so they, in fact, had used 1 mil in the rejuvenation studies. So the work with adenine at the 1 unit per mil was repeated several times to be sure that it wasn't a fluke. And each experiment verified it. There were no exceptions with multiple units of blood from multiple donors. Now to put some dates to this as to what happened. I first reported the studies to the National Academy of Sciences National Research Council in 1960. The definitive paper was published in 1962, and subsequently people both in the United States, particularly in Sweden and also in West Germany, repeated the work and confirmed it. Having made the observation, it was important to figure out how did adenine work. I was fortunate to have recruited a fellow from Japan, Yoshiki Sugita, and he and I worked out the mechanism by which adenine achieved its effect. And the initial paper, the 1962 paper, was the number 4 in my publication list, and the paper describing the mechanism was, I believe, number 13.
You had a lot in between.
So that if anybody wants to see the studies and what was done, those are the ones. After the initial observation, it was obviously important to see if it could be repeated. And so we repeated it many times, actually 6 units in about 40 different recipients. And it was shown to be effective each time. The 0.5 or 1 unit per mil adenine was added to the anticoagulant preservative solution. The work was first presented to the National Academy of Sciences, the New York National Academy of Science, the National Research Council, which were very interested in blood work because of the military application, in 1960. The definitive paper was published in 1962. It was publication number 4 in my publication list. By 64, as I recall, the work had been confirmed in Sweden and in West Germany. And in 63, I recruited a research fellow from Japan, Yoshiki Sugita, and he and I worked out the mechanism by which adenine achieved its effect. And that was published in 1965 in publication number 13. Now, what, what about, here was a research finding. The issue was, would it be practically useful? And could it be implemented in the national and international blood banking community? And in fact, by 1965, Sweden had implemented adenine supplementation in all of its blood supply. By 67, West Germany partially implemented it, primarily due to the work of Dr. Siegfried Seidel, and that was the beginning of the friendship of the Seidels, which developed from that day in the 1960s, and her last phone call was about 2 weeks ago on the occasion of Eve's birthday. So the relationship has continued with the Seidels, with visits to them in 678. We spent 3 beautiful days with them in Vienna in 2008, and we always recognize each other's holidays and birthdays. And so that's what adenine started, a beautiful friendship. Now, I haven't mentioned the United States. Although the discovery was made here, it was approved finally in 1978, 18 years later, and implemented fully by 1979, or 19 years later. Now, that's a story in itself, and that is detailed in a number of my publications, which would be numbers 27, 31, 34, and 43, but that's another story for another time. Now, I would say there's one other irony that relates to the adenine story. When I took the job at Blood Systems in 1981, part of my desire, with the approval of that current president of the organization, was to establish a laboratory for some research in blood. And I had a outline of the kind of laboratory I wanted to establish. 2 weeks later, I had a visit from a former president of the organization, and who very proudly told me that Blood Systems, as it now was called, had never spent a single dime. He was very proud to say that the organization had never spent a single dime of patients' money on research, which I listened to, but was also very interested in that the first board meeting that I attended, the financial officer said that with the implementation of adenine supplementation, the wastage went from about 10% to 1 to 2% in the first quarter, with a saving of $600,000. This having been achieved with a Army grant of about $10,000. So I think there is some justification for research in terms of even producing less wastage and financial savings. So that's the story of Adenine.
Okay, I have two questions. One, does that mean the military in all those 20 years in the U.S. never implemented that? Or was it just the civilians that didn't?
No, the military did not, because one of the things that happened, one of the very finest researchers uh, um, in the United States did an experiment on himself by injecting free adenine without blood preservative in himself and found crystals in the urine. Adenine being highly insoluble. And that set back the Army's interest for a decade.
And they didn't they didn't look at the research that was going on or the implementation in other countries? They were
It was
completely Americentric?
As I say, it is a story which is quite complicated. I'll mention a couple of features about it. One is that in the United States, the content of what's in the bag was regulated by the National Bureau of Standards at the NIH. But the bag itself was regulated by the FDA. So you had the problem. And furthermore, the sponsorship for a so-called new license application had to come from industry. Now, industry had very little interest because with supplementing with adenine, 10% of the bags, they would lose bag sales because there was less wastage. So there was little incentive.
Were these plastic bags?
Plastic
plastics?
bags. So
okay.
There was little incentive for the industry to push that.
Mm-hmm.
And I wrote 2 review articles. Those were references 18 and 29, emphasizing the importance that adenine might have and giving the background both of the studies and the experience. And those were published in 1967 and 77 respectively.
Wow.
The 77 one, I did have the opportunity at FDA to shepherd through the process.
Because by then you were over there.
Yeah, of having licensure go ahead. And the Army, there were 2 other things that were important. T.P. Greenwald, who was a dean in transfusion medicine and head of the Red Cross blood program, which at the time controlled 50% of the blood supply, indicated to industry that that manufacturer who first came out with adenine supplementation would get the Red Cross business. And so
powerful economic
that was
motivation.
an incentive. And that, along with the Army, they got together, did some additional studies, made sure there were no toxicity to platelets, that the plasma derivatives from the blood would be unchanged, and those were done. And so finally, in 78, the adenine supplemented preservative was approved by the FDA, and implementation occurred in 1979.
Wow, I had no idea it went that long, and I had no idea that you were, while you were at NIH, that was something you were shepherding. I didn't realize that at all. My second question, and you can answer it just briefly, is did you actually get to establish the lab at Blood Systems?
When I came to Blood Systems in Scottsdale in '81, I did have a plan for a laboratory, and it was basically one to study the prevention of hepatitis in the transfusion of blood, hopefully in conjunction with a hepatitis unit from the Center of Disease Control which was based in Phoenix. But two events happened that sidetracked that. Number one was that the month I came to Phoenix was the first paper that led to what came to be known as AIDS. That first paper was published in June of 1981, and the second paper in July of 1981. And my life changed for the next 14 years. I was engaged in policies that would make the blood supply as safe as possible, and what are the ethical and legal implications of testing blood, notification of donors, notification of contacts of donors, and so forth. The second reason that the laboratory was not established in Phoenix was that the hepatitis units from CDC moved back to Atlanta.
Mm.
So that collaboration did not occur.
Okay, you can
Another
continue.
answer to your question as to why it took so long and what the steps were required, there's a summary that I have in this book called A Pictorial History of Blood Practices and Transfusion. And my summary of that is on page 233. And for those who are interested, there's a picture of me on page 238. That's it.